Okay, you're given this function right here. Asked to find f prime, which you've indicated that this is correct, and it is. And we want to know for what values does f of x have horizontal tangents. That happens when the first derivative is equal to 0. So let's see what's happening. The red graph is the graph of the original function. Notice that f of 0 is undefined because you can't take the natural log or the log of a non-positive number. The green dashed line is f prime. And here's another form of f prime using the product rule against this function, and this agrees with your answer. Another way to visualize it is that each term contains x to the 1/2. So if you factor out an x to the 1/2, you've got factored form. And now it's fairly simple to solve that equation for x when that derivative equals 0. So here it is set equal to 0. By the zero product property, either this factor has to equal 0 or this factor has to equal 0. Well, we've already seen that 0 is not in the domain of the original function, so we can reject that answer. But when does 1 plus 3/2 ln of x equal 0? Well, when 3/2 ln of x equals -1, multiply both sides by the reciprocal of 3/2, 2/3. So ln of x equals -2/3. Now, some teachers or textbooks will say exponentiate each side to isolate x. I just like to say I'm going to convert to exponential form by the definition of logarithm. If I raise this base to this exponent, I get this anti-logarithm. So e to the -2/3 is equal to x. And that's what I have back here on board 2. X of 1 equals e to the -2/3. There is the point on the function where it looks for sure like there's a horizontal tangent line. And notice that's where the first derivative also equals 0 at e to the -2/3, or about 0.513. There you go. Hope that helped. If you have any questions, post a comment.